Hey everyone, welcome. Today, we're going to unlock the parabola. We're going to see how just by changing the way an equation is written, we can instantly reveal all the secrets hidden in its graph. It's pretty cool stuff.
So, a parabola's equation basically comes in two different outfits. On one side, you've got the standard form. It's fine, it has its uses, but trying to picture the graph from it, it's kind of like a messy puzzle. But on the other side, you've got vertex form. Now this is like having a clear map that shows you the single most important point right away, the vertex.
And that really gets us to the big question, doesn't it? How do we take that messy standard form and turn it into the super clean, easy-to-use vertex form? Because if we can do that, we can instantly find that vertex, and that is the absolute key to understanding the entire curve.
But why do we even care? Well, it turns out that finding the vertex is a genuine superpower. In business, it's how you can pinpoint the exact price for maximum profit. For physics, it's how you predict the arc of a rocket or a baseball. Suddenly, this isn't just abstract math anymore. It's a tool for seeing the future.
The technique we're going to use for this amazing transformation is a classic one called completing the square. I know, it might sound a little intimidating, but trust me, it's just a logical, step-by-step process. Think of it as a little magic trick. Let's walk through how it's done.
All right, let's get our hands dirty with an actual problem. We're going to start with this equation right here. f of x equals x squared minus 6x plus 5. Our mission is to take this standard form and rewrite it into the much more helpful vertex form without actually changing its value.
Okay, the secret ingredient for this whole process is something often called the magic number. This is the special value that lets us build what's called a perfect square trinomial, which is really just a fancy way of saying an expression that factors down perfectly. And the formula to find it couldn't be simpler. You just take that middle number, the b, divide it by 2, and then square the result.
So the whole thing happens in 3 simple steps. First, we just put some parentheses around our x terms to group them together. Second, we calculate our magic number, which in this case is 9. And third, now this is the really clever part, we add and subtract that 9 inside the equation. It's like adding 0. It doesn't change a thing, but it perfectly rearranges the pieces for our next move.
And that's why we did that little balancing act. Those first 3 terms we grouped together, the x squared minus 6x plus 9, now make up that perfect square trinomial we were hoping for. And that means this group can be factored perfectly.
So let's bring it all home. That x squared minus 6x plus 9 factors down beautifully into x minus 3 squared. Then we just combine the numbers left hanging out, the negative 9 and the plus 5, which gives us negative 4. And just like that, bam! There it is, our vertex form. The vertex is now staring us right in the face at the point 3, negative 4. No crazy formulas needed.
Okay, so now for the real payoff, the graphing. This is where vertex form really shines. We can get a complete mental picture of the parabola without having to plot a bunch of points or do any more calculations.
Let's take a look at a new equation, one that's already in vertex form for us. f of x equals negative 2 times x plus 1 squared plus 3. Every single piece of this equation tells us something specific about what the graph looks like. First up, the vertex. You can literally just pull it right out of the equation. Remember, the general form is ax minus h squared plus k. So for x plus 1, our h value is actually negative 1. The k value is plus 3, so the vertex is at negative 1, 3. It's that easy. So what do those h and k values actually mean? Well, they're just telling us how the graph has moved. Compared to a basic y equals x squared parabola, this one has been shifted to the left 1 unit and then up 3 units. The vertex form tells you exactly where the whole curve is located.
And what about that number hanging out in the front, the a? Well, that negative 2 tells us 2 final crucial things. Because it's negative, we know the parabola opens downward. And because the number itself is 2, it's been stretched vertically, making it steeper or skinnier than a standard parabola.
All right, before we wrap up, let's talk about a couple of common traps. The process is pretty straightforward, but there are 2 mistakes that almost everyone makes at first, so let's get ahead of them. First, watch out for the signs. The formula has x minus h, so if you see x plus 3, that's the same as x minus negative 3, which means h is negative 3 and the graph shifts left. A really good trick is to just ask yourself, what value of x makes the inside part 0? Here it would be negative 3. The second big pitfall is dealing with an a value when you're converting. If you have something like a 2x squared, you absolutely have to factor that 2 out from the x terms before you do anything else. It's a critical first step.
What we've really seen today is that by simply rearranging an equation, just by looking at it from a different angle, we can reveal all of its hidden properties. It kind of makes you wonder, what other mathematical secrets are hiding out there in plain sight, just waiting for us to find the right formula to unlock them?